Welcome to The Debate. Today we are wading into, what might be the most audacious theoretical physics proposal of the modern era, the Unified Chronofractal Field Theory, or UCF. This is a framework that's anchored entirely in a single geometric axiom, the golden ratio conjugate, nu, that claims to solve both dark matter and dark energy. Parameter-free.
And it's a theory that, on paper, it achieves a level of unification and mathematical elegance that really should make any theoretical physicist just stop and admire it. But I think that elegance hides some profound risks.
It does, and that's really the central question for our debate today. Is UCF's extraordinary success in unifying physics across all scales, from galactic rotation to cosmology, with just this single constant, is that proof of its fundamental truth? I'm going to argue that its unified derivation of hard cosmic parameters and its complete elimination of dark matter confirms its superior structure, its parsimony.
And I'm going to take a different tack. I'll argue that while the math is beautiful, UCF's pursuit of this absolute theoretical closure forces it to integrate highly speculative, non-empirical axioms. I'm talking about consciousness specifically. And that, combined with an extreme, almost binary sensitivity to its own predictions, well, it undermines its methodological rigor. It just makes it too vulnerable.
My position really comes down to parsimony and predictive scope. When we evaluate competing models, we have to ask which one describes the universe most efficiently. UCF is just algorithmically superior to the standard model, to lambda CDM, because it does everything with one single geometric definition, nu. You compare that to the standard model, which needs three separate, independent, and frankly, arbitrary hypotheses: dark energy, dark matter, and inflation.
The efficiency is compelling. I grant you that. But, efficiency doesn't guarantee truth.
But that efficiency translates directly into predictive precision, and that's where the theory really stakes its claim. So look at cosmology, specifically the dark energy equation of state, W. The standard model either assumes W is exactly -1 or it requires you to fit parameters. UCF, on the other hand, it just gives you a parameter-free derivation. W0 equals -1 plus V3. It's a hard-fixed, non-fitted prediction of about, -0.794. It flows purely from the geometry.
And that is a huge conceptual leap away from the standard model.
Absolutely. And that unification carries all the way down to galactic dynamics. UCF gives you a zero-parameter solution to flat galaxy rotation curves. It completely reframes the missing mass problem by replacing dark matter with something called the historicity field key. And this field, it isn't a new particle. It's an inherent geometric property where gravity scales with mass and the system's age. The theory achieved a stunning error of only -0.012% on the NGC 2683 galaxy without a single dark matter particle. This is why we have to take the ANU axiom seriously.
Okay, I fully acknowledge the mathematical consistency. The derivation of the historicity field, the fixed nature of W0, it's breathtaking work. But I have to challenge the parameter-free claim right out of the gate. While the theory later analytically derives all these connections, the archival documents show that initially they had to introduce a universal calibration constant, C universal, just to get the units right for the historicity field equations.
But that constant, C universal, it was subsequently proven to be analytically fixed by the axiom itself. It was derived as C univ equals nu3 root 2. It was never a free parameter to be tweaked. The loop was closed.
They closed the loop, yes, but that initial reliance on an external constant, it introduces a methodological tension. And this tension just gets amplified when you look at the consequences of these rigid predictions. The theory tries to achieve this steel-like certainty, but in doing so, it makes itself exquisitely fragile.
Rigor shouldn't be confused with fragility.
But look at the dark energy prediction. W is approximately -0.794. That's a single, non-negotiable point. USETCF has bet its entire cosmological pillar on what they call the G8 gate, the upcoming high-precision Euclid data. If Euclid tightens the constraints around the standard value, say W equals -1.00 plus or minus 0.01, USETCF is entirely, catastrophically falsified. There's no room to adjust. And that level of vulnerability, it's just unprecedented for a major theory.
And that willingness to risk total collapse on a single measurement is, for me, precisely the hallmark of real scientific courage. Let's dig a bit deeper into the galactic dynamics, because that's often seen as the most successful part of the theory.
You mentioned historicity.
Exactly. I see why you think the system is fragile, but let me offer a different perspective on the historicity field. UCF is completely unique here. It's the only model that links rotation speed scaling to both mass, m.25, and a system's age, tau-1.2, all from one geometric principle.
And what does that mean conceptually?
It means that the discrepancy we see, what lambda CDM calls missing mass, UCF interprets it as missing time memory, or historicity. The system's geometry retains a memory of its own assembly, and that memory, governed by the fractal exponent v, generates the gravitational effects we see. No exotic particles needed. And that makes it far more predictive than NFW models, which, they need 2 free parameters for every single galaxy just to get a fit. UCF uses 0.
That's a compelling case for parsimony, I'll grant you that. But that elegance comes at the cost of extreme observational vulnerability. The historicity field, chi, it relies on the system age tau raised to that exponent nu. So the theory's success is hugely dependent on accurately assessing a galaxy's age. And for distant objects, age estimation is, well, it's a significant challenge. A slight miscalculation in tau gets exponentiated and your velocity prediction shifts dramatically. Suddenly you have massive errors where the theory claims 0.
Those are observational challenges that all cosmological theories have to deal with, not a theoretical flaw unique to UCF. We're talking about the structure of the model itself.
But the structure also requires specialized fixes. The theory explicitly requires a local screening mechanism, gate G7, to suppress this field chi field in high-density regions like our solar system, just to make it consistent with general relativity. So if the theory is derived from a single universal axiom, why does it need local suppression mechanisms? It suggests the field's behavior isn't universally simple after all. The need for G7 just seems to undermine the whole concept.
The G7 screening isn't an arbitrary fix. It's a standard requirement for any modified gravity theory to pass solar system tests. It just reflects the density dependence of the historicity field. It defines the boundary where GR dominates. It doesn't undermine the universal derivation at all. Now, let's move to the part of the theory that I think really crosses methodological lines.
Agreed. I'm sorry, but I just don't buy that the integration of consciousness, specifically via this lambda term in the master equation, is a necessary element of a physical theory.
And why isn't it necessary?
Because it transforms a model for gravity into a philosophical framework. The source material defines this lambda term as stemming from a consciousness pilot space which supposedly steers the universe away from maximum entropy. It's designed to solve a problem, the hard problem of consciousness, that is, by its very definition, non-empirical. How can any prediction based on that be considered science?
The lambda axiom is introduced for theoretical closure, not just philosophical satisfaction. It's the element that solves the vacuum energy catastrophe by limiting the density of states based on VU. But the real defense against your claim is that the theory doesn't just leave lambda as speculation. It provides an immediate, local, and violently falsifiable test, the G5 quantum gate.
The quantum pillar?
Exactly. The G5 gate predicts a deviation in the Casimir force. Instead of the standard QED scaling of distance to the -4, UCF predicts an exponent of about 5.236. And crucially, it predicts a measurable force shift of 1.2% at 100 nanometers. If that local lab experiment fails, the entire quantum pillar of the theory falls, and it takes the metaphysical underpinning, lambda, with it. This integration massively increases falsifiability.
I'll concede that linking the lambda term to a measurable thing like the G5 gate is an extraordinarily clever move. It is an intellectual tightrope walk. But this reliance on hyperspecific local predictions extends dangerously elsewhere, and those predictions feel brittle, not rigorous.
Give me an example of this brittleness.
The Mars chronometry drift. It's a seemingly trivial byproduct of the theory's cosmic dynamics. UCF predicts a specific timing correction of exactly 61.6 microseconds per year in the deep space network signal between Earth and Mars.
A phenomenal result. Tying a cosmic axiom to minute signal tracking in our own solar system, and derived with zero free parameters.
But the derivation relies on highly precise, unverified inputs, specifically the local entropy ratio between Earth and Mars raised to the new power. It's a calculation of incredible precision based on inherently noisy inputs. So this byproduct is derived with zero parameter freedom, and its extreme precision makes it an easy target. The archive explicitly says, if DSN data shows a drift less than 10 microseconds per year, the theory is falsified. This level of hyperspecificity, where one small observation can invalidate a theory of cosmic geometry, that is what I call structural weakness.
That structural weakness is rigor. The theory's success relies on the fundamental interconnectedness of its geometry. If the Mars drift prediction is off, it means the entire scaling relationship governed by V is wrong, period. It means the geometry is flawed. UCF is willing to risk total collapse on the smallest data point because the entire structure has to be perfectly correct or perfectly wrong.
And that brings us full circle back to the most consequential measurement of all, the ultimate trap, the cosmological anchor, W0.
The derivation of dark energy remains its most significant victory. As we said, UCF gives you W0 at roughly negative 0.794, purely from the axiom. This removes the fine-tuning problem because the value is inevitable. The geometry dictates the expansion rate.
Right, and the result is a significant non-negotiable deviation from a cosmological constant.
Correct. A W of -1 assumes a static constant lambda. UCF's value implies dynamical dark energy, that the energy density is evolving over time, a concept that's, strongly hinted at by current DSE data. UCF naturally explains this.
That alignment is intriguing, but the profound methodological gamble remains. UCF has risked everything on this single non-fitted parameter. The moment high-precision Euclid data from the Jate-Geat tightens the constraint around W equals negative 1.00, the entire UCF framework just collapses. The theory offers no mechanism to adjust. The W0 value is fixed by nu. This non-negotiable outcome, while beautiful in principle, is fundamentally dangerous in practice.
It's the ultimate test of Occam's razor. The model with the lowest description length should be the most fragile, yet the most predictive. UCF satisfies both. It has to be perfect or it's nothing.
But truth doesn't always come wrapped in mathematical perfection. Physics often requires models with necessary complexities.
To summarize my position, UCCF represents a paradigm shift. All physics flows from one geometric axiom, unifying galactic scaling, the dark energy equation of state, and quantum anomalies into a maximally parsimonious structure. The theory's power is in its deep unification and its willingness to accept these hard, non-fitted predictions.
And to summarize mine, UCF offers undeniably compelling and elegant solutions to long-standing problems like dark matter. However, its reliance on an all-encompassing axiom leads to both extreme predictive rigidity, the Mars drift, the Casimir exponent, and the troubling incorporation of what might be untestable constructs like the consciousness field. We have to ask if unification achieved this way ultimately sacrifices the methodological purity needed for robust empirical validation, making the theory fragile despite its elegance.
The true test awaits in the data.
It does. I think we both acknowledge the extraordinary nature of a theory that links a single constant V to phenomena across such vast scales. The fate of UCF rests entirely on the forthcoming high-precision data from the G-gates, G5 in the lab and G8 in the cosmos.
All right, let's dive into a truly radical new theory of the universe. For decades, this has been the central puzzle in physics.
We call the missing pieces dark matter and dark energy, but really, they're just placeholders.
So what if the problem isn't missing stuff,
but how we actually think about time.
A new theory, UCF, says the universe's biggest mysteries can be solved by just one single number.
And that number is nu. It's a constant derived directly from the golden ratio. First up, UCF redefines time itself. See, it's not a straight line, it's a fractal.
This leads to a wild concept called historicity, where the past physically influences what's happening now.
It's like gravity has a memory, creating effects that we just misinterpret as dark matter.
So, the point is UCF gives us brand new explanations for these huge cosmic puzzles.
Okay, bold claim, but what's really interesting is how this theory demands to be tested. It calls itself maximally falsifiable. It gives us hard numbers. Hit them, or the theory is just wrong. First, it makes a really precise prediction about the nature of dark energy. UCF predicts a value of about -0.794, and that comes directly from the Newton constant.
Now, this is a clear, testable difference from the standard model's prediction of exactly -1.
And the theory also makes predictions at both the quantum and the solar system scales. It predicts a change in the quantum Casimir effect, which would actually alter a core physical constant. And get this, it also predicts a tiny timing drift between Earth and Mars, one that relativity can't account for. So this basically lays out the theory's all-or-nothing bets. It either matches these numbers, or it's wrong.
So, what's the verdict? Well, these aren't just ideas anymore. They're real questions we can ask the universe.
And the answers are coming soon. Data from telescopes like Euclid will be the final judge. So, to recap, UCF replaces these mysterious placeholders with just one simple geometric idea. The whole thing is built on this one number, making it incredibly simple and, well, powerful. Think about it. By Occam's razor, a theory that explains more with less is just better.
The data will decide. Is this just noise, or is it a signal from the very fabric of the universe?